Hi, welcome to this video. This is for Retabili and this is from 2019. I think it's the February-March paper, and if it is, it's paper 42. And I think it's question 9. All right, 9C to be precise. Excuse me, the proton NMR of butanben in CDCl3 contains one or more peaks that show a triplet splitting pattern. State the number of peaks in the spectrum that show a triplet. Okay, so here we have a CH3 at the ends. Here we have a CH2. Here we have another CH2. And here we have another CH2. Now, a triplet looks like this. Okay, and a triplet means not the thing itself, but it must be next to a CH2. Okay, so you're next to a CH2. You're not a CH2, but you're next to a CH2. Okay, so let me get a different color. These three here are going to show a triplet because they're next to the CH2 here. These two here are going to show a triplet because they're next to a CH2. Okay, now these ones here and these ones here are next to a CH3 and a CH2. And this one at the bottom, this one here, this one is next to a CH2 and a CH2. So they're not just next to a CH2, they're next to more things. So the number of peaks are going to be this one is going to be a triplet and this one. But the ones in the middle are going to be multiplets. All right, multiplex, because they're next to quite a few protons. So the number is going to be 2. Okay. On the diagram of butanben, below, circle the protons responsible, not the ones that give the peaks, but responsible for the peaks. So the ones responsible are going to be this one. These are going to be responsible for this proton, this triplet, sorry, and this CH2 is going to be the ones responsible for that. So the ones they want circled are those two. Okay. All right, there you go. All right, so let's move this up a tiny bit. Describe and explain how the proton NMR spectrum of butanben in D2O would differ from the proton NMR in CDCl3. Okay, so we're looking for labile protons, aren't we? Okay, and how many labile protons are there? Well, from the outlet, I think I can only see one there. Sorry, they're both the same proton. These two are labile. Okay, describe and explain how. So the peaks, there would be one less peak in D2O, deuterated water. Okay, so that's describing. Explain it now. Now we've got to explain it. Well, because the NH2 protons, these protons, um, what do? They undergo proton exchange. They undergo proton exchange with the D2O, and the peak will disappear. Peak for those will disappear. Okay. All right. Let me stop this now and post it. Bye bye.